All right, so AutoValue. Let me start off with how many people have ever used AutoValue? Okay, that's good. Kevin shared something with me in confidence, and I'm going to make it public, that Kevin has never used AutoValue. And so that's good that a bunch of you also haven't as well, because I'm going to start with a little introduction to it, but specifically I want to talk about extensions, because AutoValue has been available for a while, and extensions are something new that's coming to it. So AutoValue aims to provide something called value types. In Java, we'll actually get value types in Java 10, hopefully. The chances of seeing that on Android, 0. But AutoValue aims to provide this back for current versions of Java. And so why do we need why do we need a value type, and what does it provide? So Java is an old language, and everything is mutable. Like everything in Java is mutable. Well, basically everything. We have this convention of beans. Hopefully nobody still writes beans. These are objects that have getters and setters for every single property on a class. We have the collections framework, which is actually very comprehensive. But all of the collections interfaces actually have mutators on them. There's no way to expose an immutable collection. You can expose an unmodifiable collection, which just means that when you call the mutator APIs, it'll throw an exception. But we can't actually expose something that's immutable and doesn't allow us at compile time to call like a put or a set. Java arrays are immutable. There's actually no way, unlike collections, there's no way to make them even unmodifiable. They're always mutable. And then in general, you just see a lot of conventions where people have classes that hold state, and that state has mutator methods on it. You update a location, you set a value, you set names, etc. And then finally, we have this idea of non-scalar constants, and this is when you take a type and you make it a static final in a class, unless that type itself is actually immutable. Just making it static final doesn't make it immutable. So if you take an array and you make it a static final field, you're not actually making that immutable, right? It can still be mutated. And so value types is something that aims to solve this. It's basically focusing on the immutable aspect of data, and that's what a value type is. And so if we wanted to represent a value type, this is an example. So I work at a company that deals in money, and so I chose payment as an example. And so by convention, a value type doesn't have getters. It just has the property names as methods, and then there's no setters. And the idea here is that we can only read data from this object. We can't change it in any way. If we need to change it, we need to make a new object that represents that new state. But unfortunately, like I said, Java doesn't have value types built in, and that's what AutoValue is for. So if we were ignoring AutoValue and we wanted to turn this simple class into a value type, let's take a look at what we would have to do. Well, if it's immutable, we don't want anyone subclassing us and being able to override that immutability aspect. So we would make it final. And then we would just start filling in these properties with private values that we then return from our methods. And then finally, we need a way to create these instances, so we'll just add a constructor. And so now we mostly have a value type, except it's not quite a value type because we're missing some essential things if we wanted to work with this in places other than simple usages. So one is toString. We want some way to just represent this if we're logging it, printing it out, or debugging. And then if we want to use it in a map as a key or a set, we need equals and hash code, even just to compare two values. And so this is getting small for a reason, because it's ridiculous. It's ridiculous to be writing this entire, essentially, we'll say 20 odd lines of boilerplate when we started off with that initial 4-line representation that really declared exactly what we wanted. And what's even worse is that if I want to go into this and say we're going international and I want to start putting currencies in my payments, well, what do I have to do to this class in order to just add a property? Well, a whole bunch of things. I know it's super small. That's kind of the point. There's eight things that we had to do. There's fields. We got to update all of the toString equals hash codes. We got to make sure that it's propagated through the method. We got to make sure the signatures, the constructor parameter in the field, all the names match, they're the same type. If one of them is nullable, so here I'm kind of ignoring null, you have to deal with null in the equals and hash code methods and make sure you get them correct. It's ridiculous. And this is the type of code that is highly prone to error, the type of code that no one should be writing. And I know you can say that, oh, well, IntelliJ will generate it for me, except for when you have to go and add that property, it's not going to update all those different methods and the fields for you. You actually either have to delete the implementation and regenerate it, or you just have to hope that you know how to update it correctly. So like I said, Keynote struggles with this animation. There we go. Like I said, this type has all the information that we need, right? We actually don't care what the implementation is. All we know is that we want an object called payment, and we want it to have these 4 fields that are these 4 types. We shouldn't have to provide any additional information because that is all you need in order to generate all that other crap. And that's exactly what AutoValue is for and why you should use it. So what does it look like? If we go from this ideal representation in syntax, how do we get to that actual value type? Well, the first is an annotation. AutoValue is an annotation processor. So any type that we want to turn into a value type, an immutable value type, we annotate. And then because the implementation of this is going to be provided for us, we turn everything abstract. The class itself is abstract, and the properties that we want generated for us are also abstract. You actually can have non-abstract things in this class. So if you have like a derived property, if you're combining the amount and the currency into like a display string, you actually can still put that method in here that calls into the 2 abstract methods, but it's not itself part of the value object. And then because this is abstract, we need a way to construct it. And so this is our public API, so we're just going to put a static method on it, which is a factory. It's going to be a thing that takes in the raw primitives, which we want to encapsulate in our type. And you'll see that it's calling into this class, which I haven't shown. It, by convention, is the same name as your class, except prefixed with AutoValue. And what is that? Well, it's all that crap that we didn't want to write, except now it's generated for us. It's generated for us, it extends our class, so we have these 4 methods are implemented, and all we have to do is reference it in that factory method. And so we write those 6 lines of code on the left, and we get the private fields, we get the constructor, we get the overridden methods, we get toString equals and hash code, we get all that for free. And if you update one of these properties, the next time you compile, it's going to regenerate that entire class and it's going to be correct. Saves you from a world of hurt if you end up forgetting to update one of those 8 things. The AutoValue is part of an auto suite, I guess. There's a few projects. If you go to this is the GitHub repo, you have to click on the value folder. The README for it is fantastic. It gives you all kinds of motivations for the library, all kinds of ways that you use it, and it even gives you comparisons with other approaches to doing value types. So if you haven't seen AutoValue before, I highly recommend you go check that out to kind of fill in the gaps of what I said. But specifically, I'm here to talk about the extensions to AutoValue. So AutoValue's been around for a while, and extensions are something new because hopefully one of you has said this, but you see this convenience of creating these value types, and you're like, this is awesome. Except, well, how do I use it with parseable? Or maybe I want to pass it through JSON to use it across, the network. Or maybe I want to take my cursor and turn it automatically into this AutoValue type because I'm storing these payments in the database, or whatever. There's hundreds of these things that are inconceivable from AutoValue's standpoint, but that your application needs to use it with. And that's the whole point of extensions. So I'm going to use a couple as an example, and then I'm going to show a big list of all the ones that are currently available. Parsable is my favorite. It's the big one that kind of got us into figuring out how to make AutoValue extensions, because sometimes you just want these to be parsable. You want to be able to put them in a bundle or send them across an intent. And parsable is the fastest way to do that, right? Except going back to the whole value type thing, you don't want to have to write the parsable implementations. You don't want to have to get the write to parsable method and the creator method wrong when you update one of them. And so another thing is we actually want these types to be parsable. We want to be able to take payment and just put it into an intent and not have to use something where it's a wrapper object or you're delegating to another library every time you have to read and write these parcels. We want payment itself to be parsable. And so that's where extensions come in. So original payment class is here on the bottom, and then the generating class is on the top. And so the bottom is just our abstract properties, and the top is the implementation, that giant 40 line monstrosity. And what extensions allow us to do is detect when an AutoValue class implements parsable, and then what we do is we just shove another class in that hierarchy, which actually does the parsable implementation. And you'll see, sorry, I know it's kind of gray, but the top one, which is the AutoValue prefixed one, the one that you're going to call in the static method, is a class that's just going to implement the two parsable methods, and it's going to have the static field, the creator field, which implements the deserialization method, the unparcel. And then the value type, the actual thing that's doing the equals hashcode toString and the properties, is going to be in the middle. So the parsable class will be extending the value type class, and then the value type class will be extending your abstract class. And since your abstract class is calling the top class in its static method to create it, it never really knows about this middle class at all. It's kind of an implementation detail because you're always just referencing AutoValue payment. And now magically all your AutoValue types are parsable, and you can just put them into intents. You can put them into bundles, and you can read them from bundles because the creator method is on the topmost type, and it's going to create the topmost type when it's unparceling and give it back to you, but you're just using the interface or the abstract class. And this can go even farther, or is it further? Farther, I think. And so one of the things at Square, because we're dealing with sensitive data, in our toString implementations, because we have value types, we want to log them to see how the user's moving through the apps and what data they're interacting with. We want to hide some of those things. We want to hide what we call PII, personally identifiable information. And so we have an extension called redacted, which we can put on any of these properties. And since this is a separate extension, what this does is it just puts another guy in the hierarchy. And I know it seems ridiculous, but it's a nice separation of concerns here, because what happens is we generate a class which only implements toString. All it does is implement toString, except it omits the redacted fields. And then the AutoValue class, the normal stuff, gets generated, except it sees that you already have a toString. And it's like, well, okay, you already did that. You got toString. I'll do the rest. I'll do equals hashcode, and then I'll do all the private fields. And then finally at the very top, parsable's like, I got parsable. I'll do those two methods, and I'll do the creator field. And so you get these separation of concerns and extensions, but at the end, you're only writing these four properties, the one annotation, implementing parsable, redacting some fields. All this stuff is happening behind the scenes, and you're just referencing the topmost one, and everything else happens behind the scenes automatically. Oh, I had sweet highlights that I could have been using. Okay, so there's a few of these that are already available. The first two I already talked about, the parsable implementation. Ours, which does redaction in toString. I talked about JSON and serialization. So there's two extensions which do JSON and Mashi, which is another JSON serialization library. And what these are for is that they basically generate type adapters that can read and write to and from JSON very efficiently, and they know how to create the generated type when you're deserializing. There's one for cursor, so it basically just creates a method that takes in a cursor and returns you an instance of the AutoValue type by looking at, you can annotate properties with column names. And then the last one is, it's called withers. So because these are immutable types, a pattern you often run into is that I want this exact type, except I want to change one value. I want to update the age, or I want to update the amount on a payment. And so what withers do is it gives you methods that allow you to create a new instance of a value type, except changing one field. So you could say, I want this $5 payment, except with a $10 value. And so it copies all the properties except for that one that you specify. And then the whole thing that makes this, the thing that makes this usable and workable is this new extension API. And so those 7 things aren't going to cover every use case. You're gonna come up with something that you want to say, oh man, it'd be great if this could automatically generate, some other representation, whatever it is. And the extension API is exactly designed for that. It's to allow you to just hook into the normal process and add functionality, to mix in all these different functionalities without having to actually know how everything else in the stack works. So I'm going to go through this super quick because it's very technical, but it's also kind of simple. There's only 4 methods. The first one is whether or not your extension is applicable. And so what this means is that because we're generating classes and because we're generating methods in those classes, and because potentially you're writing hundreds of these value types, you don't want to be doing this all the time. You don't want to always be generating things if you don't actually need them. So what applicable allows us to do is say, I'm the parcelable extension, and I'm looking at this type which doesn't implement parcelable. No, I'm not applicable. Like, I don't want to do anything for this type because I don't care about it. It's not parcelable. And then for a second example, if we do see that it is parcelable, then yes, I'm applicable. And that means other methods on the extension will be called. And this doesn't stop with just implementing interfaces. You can actually just look at anything of the entire type. So the redacted extension only cares if one or more of the properties are annotated with redacted. So we look and we say, no, none of these properties are annotated, so I'm not going to waste time generating a class and generating that toString method if nothing's redacted, because AutoValue will do that automatically. And then the same thing, if we do find a redacted property, we just return true. And like I said, returning false actually means that an entire class will be omitted and however many methods you would be generated. So ideally you would find a way, if you're writing something, to determine whether or not it's actually useful to generate a class or not. And so implementing an interface is one, detecting annotation is another great one, because this is Android, we have limits, however contrived they may be, and you just want to be mindful about these things because they take up space and they have to be loaded, they have to be, their methods have to be called, all that stuff. So if you can leave it out, leave it out. The next one is unfortunate, and you probably won't care about it. It's must be final, and this is the difference between parcelable and redacted. The parcelable extension, it has to make that creator static field, if you've ever done parcelable, that has to be on the last, like the actual implementing type. So that creator field can't be on like a between class, and then there's another class that extends from it, because it's not going to be able to, when it unparcelables, it's not going to know to like, I have to instantiate another class that's not me. And so must be final just is like, do you have to be the last class in the chain? I really can't think of another reason to use this other than parcelable. I'm sure there's ones out there, but the idea is that it basically just switches where your extension class gets generated. You're either between class or you're the end class. Probably will never need that. And then another interesting one that actually comes from parcelable is sometimes you want to consume properties, and this basically means you want to hide things from original, the like normal AutoValue stuff. And again, parsable is a great example here because the parsable interface has two methods on it. It has one which is write to parcel, which is the one that's everyone implements and thinks about and knows about. But there's another one called describe contents. And so if your extension just says, you know, I don't want to consume anything, you're actually going to find that your generated class has your note field, your field that you wrote, but then it also has the field that came from the interface, which is describe contents, because it's a method that returns a type and takes no arguments. That's a property, and so AutoValue is going to treat it as a property. And so consume property basically just allows you to say, don't worry about describe contents if you're the parsable extension. Or if you're the wither extension, the extension that's adding the with methods, you can say, don't worry about these, I got these. And then finally, you just have the callback to generate a class. And so here you'll see you have all the information you need. You get the class name that you are. So AutoValue is going to automatically figure out which $ class you are. You know, you'd be like $ AutoValue payment. It's going to give you the superclass, the class to extend. So if you're the final class, you'll get another generated class. If you're not the final class, maybe you're extending from the class that the user wrote. And then there's also a Boolean as to whether or not you should mark your class as final, because only the topmost class is final and every other one is abstract. But so I know that's kind of a lot, and I kind of went through that quickly. If you're building an extension or you want to build an extension, look at the existing ones. They're fantastic resources. They've bared the burden of going through the development of this API and figuring it out. And the other thing is try to play nice with others. And this really comes down to the whether or not you have to be the final generated class or not. So the fact that parsable has to be the last class means that no other extension can also be the last class, because you can't have two last classes, right? So that's an example, and the consuming properties one is another example. Just if you implement an interface that has properties, make sure you're consuming them and not affecting other extensions. If you look at the 4 extensions the 6 or 7 extensions, you'll kind of see these 4 libraries over and over again. This is basically what you would use to generate generate classes. Java Poet allows you to write kind of a higher level abstraction of generated Java. Truth and compile testing, 2 libraries from Google, which are fantastic for testing these things. They really do a lot of the heavy lifting of running the extension and being able to test the generated code. And then finally, auto service. In order for AutoValue to find your extensions, you have to opt into this mechanism called service loader, and it's a little more complicated than you really want to have to deal with and remember. And auto service is basically you just annotate your extension, and it takes care of all that for you. So unfortunately, there's kind of an elephant in the room with AutoValue extensions. Right now, it's not in a released version, so there's no like stable release that you can depend on and get all this functionality. And that's unfortunate. So really, you can only look at the latest snapshot. So hopefully these will be in 1.2, which will be released for the last 6 months, will be released. And so just to show you a little timeline and do a little public shaming, a long time ago, there was something called the Big Bang. Started off with an explosion, and then 14.5 billion years, or trillion, whatever it is, went by, and AutoValue 1.1 was released. And that was awesome. That's the current release. And then right after that, about a couple weeks, the extensions API was merged. And so that's been about 9 months. And so jump forward about 9 months to today, and hopefully sometime between now and the heat death of the universe, we will have AutoValue 1.2. They keep saying it's coming. It's a really powerful API, and I understand the delay, right? Like you can't go back from this. You have to get it right, and once it's out there, all these extensions will have proper releases, and you'll be able to depend on it. So I had hoped it would have been done by the time of this talk, because I signed up for this like 2 months ago. But there's still no 1.2 release in sight. So if you do have to use this, either depend on the snapshots. Unfortunately, because of the awful setup of the auto repo, you can't use something like Jetpack. So you might have to grab like proper jars and check them into your repo, which just kills me inside. But it'll give you stable releases. And it's a really powerful feature. And if you're writing stuff like this by hand, stop and use AutoValue. And that's all I have. Thank you. I will take a few questions if anyone, yes.
Two things. One, in a real lay explanation, one of the primary use cases for AutoValue is just to reduce boilerplate code. Correct?
So one of the primary use cases is reduce boilerplate.
Yeah.
Yes, and just prevent error.
Okay.
Because inherently these classes are going to change, and when they change, you have to change all of that stuff. So it's not hard to do that once, and IntelliJ will generate it for you once. It becomes a problem when you have to start changing them. And so this just removes that from the equation.
More mistakes occur when you have to
Exactly,
do stuff.
yes.
Second thing, you showed us some of the extension. Is there currently a Jackson extension that you're...
I could not find a Jackson extension,
Okay.
Just JSON and Mashi. It would be trivial to copy one of those two and create the same thing.
Cool, thanks.
Roman.
Is it possible to have nested auto values, like an auto value that has like an auto value as a field? And if so, are there exceptions?
Can you nest them? As in having an auto value type as a property inside of another one? Absolutely, and that's kind of another thing, the huge advantage is these things are immutable, so you can basically use them anywhere, including in AutoValue itself. And another thing I forgot to mention, you can put like lists and stuff as properties, but because they're still immutable, by convention in that static method where you create the AutoValue type, you want to do a defensive copy. So if someone gives you a list, you create a copy of that before you call into the constructor of the generated class, just because you want to enforce the immutability. You do a defensive copy and you wrap it in unmodifiable. Or if you have the benefit and you don't really care of putting Guava in your app, definitely use like immutable list, immutable set, and all the immutable types that Guava or any other competing library provides, because you want all the exposed properties to themselves be immutable. And that's why it's great to use them nested, because they guarantee that for you.
Do
Yep.
you use multiple interfaces, like pressable, comment, something else, and it'll just deal with it with the multiple classes in between?
So can you use multiple interfaces? Yes, as long as they don't clash, and as long as...
If parsable is final, you can't have any other finals in the chain.
Right, so parsable is kind of a special case, but if you're just generating like... I don't know what another example of an interface is, but yeah, if you just have interfaces that have methods on them, you can even let AutoValue create properties. So if you have an interface that's like named, and named just means I have a method that returns a string for name, the name method, you can implement that interface on AutoValue types and just let it generate the properties for you. But yeah, if you have multiple extensions that can handle multiple interfaces, as long as they don't clash in some way, it should totally work fine. All right, thank you everyone. Back to Kevin.